Hello everybody, I am Shahriyar Rajabli. Today I will talk to you about one GeoAI model. This model is building detection model trained by me and my colleague Ruslan Hüseyinov. Now I will show you our models predict results. Let's check our models predict results. This territory is Azerbaijan territory. This is Baku territory. Now you see how our model is predict. Our model predict all of buildings. I think that this model is custom trained model. I think that model give us good results. Now let's check some of examples. You can see here all of buildings predicted by model. Someone thinks that there doesn't any buildings, but model cannot find this territory, but I want to tell that our model thresholds is 1.9. If we decrease this thresholds 1.8 or 1.7, our model can find all of buildings. I think that this is very good model results. Someone knows that Esri has building detection footprint models. We also use these models, but why we decide train our models? Firstly, we want to learn how Esri API can train models and how we export training data. We want to learn this process. Second, since in our work we need some building detection model for locally, that's why we decide to train our models. I want to talk about some information about our models, how we train models, which data we use, which image, satellite image use or drone image use. Let's firstly check our models instruction, how our model trains. After this process I will show you all of things, how we can train our models customers. This is our models model pass. There have also models DLPK file, EMD file, and model characteristics. We can check it. There has loss graph. We can see here train and validation graphs. We can see how our models train. I think that our models train is good in these sections. There have also results, image predict results. These models give us this image. Also, I want to show you our models EMD files, because someone thinks that this is not our model, but I want to show you this is our model. We use backbone is ResNet 50 models. Everyone knows that Esri API use PyTorch library in backend. That's why you can see here is the back is PyTorch. Here you can see ArcGIS Learn libraries. ArcGIS Learn libraries is famous libraries and most important libraries for Esri deep learning users. You can see here is our class names. Class name is Chile. This is means these buildings. This is my native language, right? My native language. We use 30 centimeter image resolution. Here is 30 centimeter image resolution. Our wiki and coordinate systems. Also, in here you can see our model names or exported image. We export image chips 224. This is our image height and image weight. We talk about this. Our learning rate is 1.31 blah blah. This is our models learning rates. Okay, you see our models EMD file, how our models work, which data use. Now I want to show you all of pupils how model is predict. Someone thinks that this is not deep learning predict results. This is cadastral data, but now I will show you how our model is predict. I find some random place. This is normal place and predict with my models. In this predict process, now I use ArcGIS Pro. Esri companies support us two options. We can use deep learning models in ArcGIS Pro or ArcGIS API. We also use ArcGIS API and ArcGIS Pro because ArcGIS Pro give us some tools with now I show you very quickly. Okay, in geoprocessing menu I use detect object. I use detect objects. Now I choose my imagery. My imagery results here is 10 centimeters. I told all about things. Now we choose our models. My models is building detection, trained models, our DLPK files. I zoom in. I want to predict little territory because this process take some minutes. Now I want to take little process, little territory. Now I want to now tell some, just I run models after we speak. I doesn't change any parameters. I want to run our models only default parameters. Now I write here parallel processing factor because my computer has GPU. Now our cell size is trained cell size and image cell size. Processor type I choose GPU because our computer has GPU. Give ID. In this section I choose my extent. Every give us a lot of options. Which one do you want? You can write. Now I only choose maps extent. Here's our map extent. Now I want to run this. Okay. This process is when finished. I have some notes. Now we talk about this first image requirements, second algorithm selection, and third training process. One is image requirements. Before I told you our trained model use. Yes, now I show you our model is predict result. Now here I think that this result is very good. It's little territory, but our model find all of buildings. Now I want to show you our threshold is 0.9. If we decrease some of territory, our model find very good. This is very good result. I think that I change these colors. No colors, outliers, red colors, always very good. Okay. Now you see how is our model's results. Let's talk about image requirements. This model trained model's image requirement use 30 centimeters. I want to tell about you, if you want to get higher resolution image, if you want to get good result, good predict result, our image resolution will be under 50 centimeters. That's why we get good result. I remember that I train additional GeoAI models. I use 1.50 meters image resolution, but I don't get any good resolution. I cannot find some buildings. That's why if we want to get good resolution, good predict results, our image resolution will be very good. We must use high resolution satellite imagery or drone imagery. You can see here how is our predict results. I think that it is very good results. Before I told you Esri company has building footprint detects. Yes, has building footprint detects. We know that this building footprint models doesn't train in our regions because this models trains for other foreign countries buildings. That's why we cannot get some good results in our country, because this is not model problems, this is region problems. In our region has different architectures buildings and different roof types. That's why my colleagues and what decide to train our models, because we have high resolution imagery and we have second processed data. We have vectorized data shape files. That's why we decide to train our models. Okay, my second note is about algorithm selection. Which algorithm we use in behind these models? We use Mask-CNN model architecture. In the world, all of famous models, all of people use Mask-CNN architecture because Mask-CNN architecture is give us very good resolution. That's why we use Mask-CNN and backbone is ResNet 50 model architecture. If someone want to learn about Mask-CNN, what is Mask-CNN model architecture, how Mask-CNN is work, I offer you firstly Esri company. I always tell that has good documentation. You only search from browser ArcGIS IP object detections. Here's object detection models and ArcGIS IP Mask-CNN. Here is the first stories about some Mask-CNN. This is Esri documentation. You can read here all of things here. So how Mask-CNN works, why we must use Mask-CNN. I can only tell that Mask-CNN model architecture is very good object detection, not only building detection, object detection. Here also I write my stories under these videos. I have some stories about what is the Mask-CNN and how is it applied in GIS, how we can use Mask-CNN in GIS. I wrote here all of things about Mask-CNN and applied of Mask-CNN in GIS. Also I wrote here Esri companies GIS models and their experience. We can see here before I told you Mask-CNN is used object detection models. Esri company here have some model architecture solar panel detection. In here Esri company use Mask-CNN model. Car detection, this is object detection models. Esri company also use Mask-CNN model. Agriculture field delineation, Esri company use Mask-CNN. All of famous companies to Esri companies use Mask-CNN for object detection. I think that this is very good algorithm architecture for object detection. If someone interested about this, you can write or you can learn. If you want to test, this is very good. Okay, let's check my other notes. Third process is training process. The training process consists of 4 main stages. One stage: data collection, data pre-processing, model training, and model evaluation. Okay, now we talk about the what is data collection. Data collection is that I tell that Ruslan and me, we doesn't collect any data because our company has some cadastral data. This data vectorized only 30 centimeter imagery. That's why we think that why we doesn't train our custom models. We have high resolution imagery, we have collection data. This model is trained about I write here about 6060 shape files. We use building shape files used, and we write in code some data augmentation, and we increase this images. Okay, first we told that we need data collection. Now I will show you how we must collect data, how we can collect data. If someone interested this, they use this information. Okay, I show you. Okay, firstly we need some images. By the way, I told you we predict and we use all of the images. We have image service. This is not raster image. This is not a TIFF image. Firstly, I get all of images from our company. I create map service. After this process, we make a cache and tile service. In this service is cache and tile service. I make this service cache and tile service. That's why this service speed. This is of Baku territory. Service speed is very good. Firstly, we cache, but Esri now Esri building detections labeling tools doesn't give any options for export training data from service. Now I add here one GPH files, some layers. Okay, this if I click here, you can see, I show you, and labeling object doesn't see our map service. This see only this folders. We need only GPH or TIFF files. That's why we doesn't export image service, map service directly here. I don't tell image service because I never use image service. I only use map service or tile caching service. I can tell that doesn't see this. If you use these parameters, train samples, this time you can export your data directly. Okay, now I have one GPH files. This file says coordinates, some coordinates. Now I show you how we can use label objects. What is labeling? Labeling is these things. We tell our models, our machines, this place is building. We create some shapes and tell our machines, deep learning models, this place is building. This, when we use this labeling tool and export our labels, it gives us one image, one labels. Image is equal labels. That's why we must export our training data. Okay, I choose OK button. Here I have one window. I put here one with the first we must create our schema. Our future class, our class names. What will tell? Okay. Building our name, we must give some value, and I choose color. Okay, I vectorized my buildings. I don't have any time, I only make 3. Okay, you imagine that we collect all of data from our image. I think that this is enough for training data, but you can collect a lot of data. After this process, we must save our shapefile. This is shapefile. Every company give us some options. One option is this image classification panel. We save these shapefiles. I add here building, export. Okay, building export. If we want, if you collect all of data yourself, you have all of labeling data here, this panel. This time you export your training data here. Okay, now I show you. This is output folder. Which folder we save our image and chips. I choose here. I change folders, different name, test. I choose some folder. Yes, we doesn't have any test folders now. I choose my folders. Link detection, test models in there. I remove all of this before. Okay, I choose this image. I don't create any file. We must choose in this place image format. DRF format, GPOR format. We always use GPH format because TIFF format folder size is very big. That's why we always choose GPH format. This format gives us a small folder size. This is useful. Tile size, it will be different. It is your options. Now I don't change any tile size right because I want to only show you process. And it is metadata format. This is algorithm options. There are different kind of algorithms. Which one do you want? You can choose. We choose MaskRCNN for object detection. Our expert training data process is ready. I only click run. Okay, I show you. Yes, you see that there have two folder, images and labels. We cut all images. I want to tell you my image resolution is exactly 1000. Now we told our tools cut all of image 256 grids. That's why how many image we has in this section. We have static panel. We has 26 images. Also in this section has buildings. Our building is our class names. Also we have labels, building labels here. All of files is necessary for train our models. This has also EMD file. EMD file has image weight, image all of process, how is image resolution, image grid, and class names. Class name is building. This is important, train our model. Okay, this is first stage, export our training data. Is additional stage is we use this process. Someone give us some shape files of future class. How we can use this shape files of future class? I want to open my shapefiles. Crop GDB building export. I want to open this attribute tables, this shapefiles. This shapefiles is our labeled shapefiles. They have some spatial columns about these shapefiles. When we train the models, these shapefiles give additional information in these models. This here is class names columns. Here is class value and RGB values columns. These columns, these 5 columns is very important to export training data and train models. Imagine that someone give you some shapefiles. Ruslan and me make this stage. We run this stage. Our colleague give us some data, but this data is normal GIS data. This data doesn't have any labels, any class names, any RGB values, class values. We open this data and look here. We make okay. You can see here. This is data. Yeah, I have in now sounds that or a lot of data, but this data doesn't have spatial columns. Our colleagues and different people collect this data in the fields. They give us this data, but we want to use this data in train our models, in deep learning models or machine learning models. After this process, Ruslan and me, we add in our data some columns. Which columns we need? Before I told you class name, class value, and RGB values. After we add this process, now we must export our training data. In these times, the company give us additional tools in the, from the geoprocessing tools. Export training data from deep learning. This time this process is same as before. I told you difference is only I can add these shapefiles. I choose my imagery, or in these tools you can see here I choose my map service images. Now I can choose our image service. This is all of this is my image service, not raster, not TIFF files. In this service I add my image service, but I show you before in this section we create labels. We doesn't export directly ArcGIS map service. That's why this tool is very good. We choose our service and we choose our, I now show you our what is data building expert tools. Why I told you we need class value, class names, because these tools always need. You can see here class value. Tool needs class value. Where is class value come? Class value is here. Why tool need class value? Because after exporting process, this tool must classify all of data. Which data is buildings or things that which data is cars. That's why this tool needs class value fields. We add only class values, and I told about this with these parameters. In here it have parallel processing factor and our image cell size. This is good. We told about that. We talk about with you. First process is data collection and data preprocessing. What is data preprocessing? In this time we look here. Rotation angle. What is rotation angle? When we cut our image, this time our tools rotate all of image. First time you can write here angle 19 angles. This time rotate 7 times image. All of time rotate image. Why we rotate image? Because we increase our data. This time we cut here and we rotate. This times thinks that house door is this side and we rotate towards this side, this side, this side. We increase our data. This is very important. Train our models because we cannot collect 2 million data, but we can increase our data. Use these parameters, rotate angle. Why Ruslan and me always use ArcGIS API? Because ArcGIS API give us additional parameters. This is data augmentation parameters, but only one parameter. If you want to learn about data augmentation parameters, this is very huge. It has huge capacity. There are a lot of data augmentation parameters. I only taught the flips, rotates, converts, and sharpen. A lot of there has a lot of data augmentation tools, but it is very important if you want to get good results. That's why you can increase our data. You can write here exactly not degree 45 degrees and export your data. Okay, this is we talk about data collection, data processing. When we finish data processing, we get these folders. We have images and labels. Now our data and image is ready for training. This time you can use Esri ArcGIS Pro's tools. Now I will show you. You can write in search train model. Yes, here train deep learning models. You can use in this tools train deep learning models, but I told that we don't use directly tools. We always use ArcGIS API. Now I show you ArcGIS API. Okay, if you want to learn all of things about ArcGIS API object detection, you can read all of things. In Esri company give us all of documentation how we can add our image in backend library. Esri use ArcGIS Learn. This this programming language is always use Python. This Python programming language, you can add your image. This is image. How you can export training samples using these codes. There have a lot of export training samples parameters. I like ArcGIS API because it gives us stable parameters. Not we can change all of parameters. It is very good. This is user-based API. In next section is data preparation. I told about you can add your data, you add valuing, all of things. This process is model training process. In model training process, what we need our images and labels. Before I show you how we can export images and labels, we have image and labels. Now we write our codes and we use our models. Model training session is company use ArcGIS Learn library. Under this library there are a lot of things. It's very good because if you want to train your models, you don't need find any library other size. Under this library there are a lot of things. It's very good. ArcGIS, you import ArcGIS Learn, PyTorch, FastAI, and you can train your models. Model selection depends on you. We use Mascar, CNN, architecture. Important things in train model: find best learning rate. best learning method, it is important things. I think that when I learn, and by the way, I told tell you, we test in this building protection with our code. We write PyTorch, not PyTorch, sorry. We write TensorFlow codes. All of documentation, all of codes of TensorFlow. In these times, we add some optimization and some tools, functions. We want to find learning rates. But in Esri company give us some options. This is very good functions. When we use this function, we can find automatically our data's learning rate. It is important things for model learnings. If you find the model learning, it is very good. After we find learning rates, we use these parameters in our models. Learning rates is equal 0.001. Okay, it's very good. You can add in here early stoppings and epoch counts. It is a normal model training. I write it in my, yes. We train our this model in 220 hours. This model of building detection models trained 120 hours. I want to tell you that this is depends on your computer resource. In our computer resource, train these models 220 hours. I can show you our computer resource performance. Our computer has GPU NVIDIA GeForce RTX 39. This our parameter is this. You can see here. In this parameter, train these models. We train our models 45 epochs. Yes, we train our models 45 epochs. Okay, we write all of code and afterward. Unfreeze and backbone. What is and fine tuning model? All these models accuracy above exactly 60% accuracy. In future, if we want to increase our models accuracy, this time we can use our model fine-tuning model with use export training data and epoch kinds. Also, we add in this section of training process our models. Dear Pekka, why we add these models? These models help us to get good results, good train results, because our pre-trained model has good image weight, good trained weights. New model get this weight is very good in deep learners. Our new model get these weights and learn very good. This is important things too. Okay, all of sims. I check my, yes, we train our models, and next is model evaluate. Yes, we write in code and management evaluate model, and you create your visualize results and code. We always use code, but now I show you this. Okay, let's create some test with our models. We have some territory, Karabakh territories. Why I want to tell that why we need these models, why we create these models, because our company want to detect our some territories, some Karabakh territories. We want to check all of buildings, how many buildings have. If people work this place, there are a lot of times because there are a lot of buildings and infrastructure. That's why we train our models. We detect all of image exactly 30 minutes. That's why this is very good things. You can see here all of buildings detected. Very good. Okay, now I want to predict some territory with our models. Our model, I told you train it 30 centimeter images. This image is 30 centimeter images. Let's predict using detect object tools and see how detecting this. Before I predict in Baku region, 10 centimeter orthophoto image, but this is satellite image. Look in this sides. We train our model 30 centimeter image resolution, but before I train our models in Baku 10 centimeter aerophoto imagery, they have some difference because our model is now have some good results. We train our models 30 centimeters, but we get good results 10 centimeters. This is very good. Now I choose 30 centimeter image resolution. I choose my models. I don't change any parameters. I want to choose default parameters. I only choose extent parallel processing factor. It is if you choose high parallel processing factors, your model cannot run. First check your GPU parameters. It is important things. If you want to train deep learning models and machine learning models, not machine learning, deep learning models, you must be your computer must be GPU, because GPU help us get good result. GPU save our times. GPU is important for detect objects. Not labeling is. Now I show you. Yes, you can see here how is our model result is. I told you my threshold is 0.9. I think that it is very good result. We train our model only first time. If we collect any data and we use any data augmentation tools, and we must use some pre-trained model, we train again it accuracy we can increase accuracy. Okay, we come Baku territory and predict some different territory. I think that is enough for us. I find different territory. Firstly, which territory we have some additional place. Yes, I want to find here, predict here, and finished our presentation. Okay, now I change my image, our image now 10 centimeters. I change only extent as the parameters. Okay, run. Now run. Custom Esri company has give us good options if we want to train our models, or we use Esri pre-trained models. It is very good nowadays, because all of people now use AIs. In this section, GIS section, we must use GeoAI. GeoAI is very good. If you want to improve your model yourself, you can use your customer models. It saves people's lives. I think that we can extract all of data from satellite images or drone images. By the way, I have some models we train drone images. Image resolution is 8 centimeters. I think that we get in here. One day maybe I show you, we talk about in these models. Now, if someone vectorized this place, I think that it has only 1 hour or 30 minutes, but now we export all of buildings exactly 2 or 3 minutes. It depends on our computer resource, but in my computer resource exactly 2 minutes. It gives us 2 minutes extract all of buildings. This is our customers trained models. Oh my god, it gives us very beautiful results. Very beautiful results. Super. I believe, yes, I believe it gives us super results. I open it. Okay, I want to clean files and my favorite color, red colors, and how is all this? This is normal, not normal buildings. After this process, we must use some regularized process, but this is default process, and it is normal. Okay, dear colleagues, thank you very much for attention. I just only want to show you how is our model's results, how we train this process, how pass it this process, how many data we use in this process, which computer parameter we use, which algorithm, which tools or API we use. All of that. So thank you very much. See you next videos. Thank you.